Section 6.2 is more stuff about the normal distribution. So first of all, you could transform any other normal distribution to the standard normal by standardizing. So just going back to when we talked about this, when we had measures of relative standing and that sort of thing, you just subtract the mean, divide by the standard deviation, which is what this is. So like if x is your variable, or I guess the value of your variable in whatever other normal distribution you've got, like let's say it's a normal distribution with a mean of 10 and a standard deviation of 4, then if you subtract the mean, divide by the standard deviation, you're going to have a value that comes from a standard normal. So you can always do that, although this is really more, I don't know, it's a bigger deal if you had to use a table, because the tables are set up for a standard normal. But for using StatCrunch, you don't need it. And like it says here, if you're going to use a table, then you do. But if you're going to use StatCrunch, you really don't. And with this example, this is just here to show that it works. So the weights of adult turkeys normally distributed with a mean of 22 pounds, standard deviation of 5. And suppose we're going to randomly select an adult turkey and we want to see the probability that it weighs at least 20 pounds. So you could do it without standardizing, which is this. So if you look down here, this is a normal distribution with a mean of 22, standard deviation of 5, right? So I didn't standardize, I just stuck in the mean and standard deviation into StatCrunch, and then I got the probability. So what I did there, I can show you. So stat, calculators, normal, and then I said I want a mean of 22, I want a standard deviation of 5, and I want the probability that x is at least 20, and then compute. And we end up there, right? 0.6554. That's exactly what's there right here, right? And these pictures are coming right out of StatCrunch too. But then you could standardize and do it. So if you standardized, notice the variable changes where it goes from x to z, because that's also getting standardized. And once you're going into the standard normal distribution, the convention is just to call the variable z. But then it's 20 minus the mean of 22 divided by the standard deviation of 5. So that's negative 2/5 or negative 0.4. So then you could do this. If I go back to StatCrunch, I would have to change my mean to 0 and standard deviation of 1 because we're talking about a standard normal distribution now. And then I need my cutoff to be negative 0.4. And then if I compute, exact same number, 6554. So sure, it does work. But I think for using StatCrunch, we don't really need to go through that transition. It'll work, and if you're going to use a table, it's really helpful, but you can usually work around this. And it kind of ends up being extra work a lot. It's worth knowing that that's a thing that you can do, but for like what we're going to do in these examples, we're not going to worry about it. So like it says here, heights of a certain population of corn plants follow a normal distribution with a mean of 145 and a standard deviation of 22 centimeters. We're going to select a corn plant at random and figure some probabilities out. So more than 150 centimeters tall. So I'm going to draw a little sketch here. And I said the mean was 145, right? That's, if I turn this on, right, we've got this up here. So that means I got to put the 145 right in the middle of the picture. Right, that's where the mean is, right at the peak. 150 is bigger. So this doesn't have to be like perfectly a scale or anything, but 150 is certainly bigger than 145, and more than 150 is going to be this. So I would just go right to StatCrunch for this. And we're going to have to make the mean 145, and we're going to have to make the standard deviation 22, and then we'll be able to get the probability that x is greater than 150. That we're looking for. So let's go over to StatCrunch and do it. So we need a mean of 145. We need a standard deviation of 22. And greater than or equal to, same thing, it's a continuous distribution. The cutoff should be 150. There. Looks like we're getting 0.4101 to 4 places. All right. So this is 0.4101. All right. Next. Between 100 and 150. Okay, so then let's see, I guess we can sketch this one out. So 145 is there, 150 is where it was last time, and then 100 I guess is kind of way back here. And then we're trying to get this, right, the in-between. So then, all right, we can go to StatCrunch. The thing that we're going to have to use is the between. So what I mean by that is if I go back to StatCrunch, up here where you have the standard and the between, you need between here. And then our cutoff should be 100 and 150. Right, same mean and standard deviation, so I don't have to adjust them. If I do the computation, there it is. Right, 5695 to 4 places. So if I go back here, then the probability that 100 is less than x is less than 150 is 0.5695. All right. And then the third one, the probability of the plant's at least 120 centimeters tall. All right, so 145 in the middle again. Let's see, 120 is a little more than one standard deviation below, because one standard deviation is 22, and this is 25 below. So I'm going to say maybe about here is the 120. And we're trying to get this, right? Because at least is 120 or bigger. So we're trying to get that. So then if we go to StatCrunch, then the thing that we're trying to get would be the probability that x is at least 120. And if we go to StatCrunch, let's see, I've got to go back to standard. And then it's already set up for an at least, we just have to have a different cutoff. So if we change that to 120, compute 8721. Looks like that's what we're getting. All right, so 0.8721. Got it. All right. That takes care of that one. Then there's another example in here. And really there's this one and then there's one after it. So this one's about fast food, where Wendy's had the shortest average drive-through time in a study. And based on empirical data, we're going to assume that the drive-through times are normally distributed. Otherwise, we sort of get stuck because that's the only continuous distribution we've talked about. But normally distributed with a mean of 138.5 and a standard deviation of 29 seconds. So, all right, 138.5 is our mean, so I guess I can draw that in here. And then the probability that a customer spends less than 60 seconds in the drive-through, the 60 is actually way down in the left tail here. So I'm going to say maybe it's about here. And we're trying to get this little tiny tail. So we should get a little tiny number with a little tiny tail, right? So let's see. All right, so with StatCrunch, we're going to need, now we got to change the mean and standard deviation. So the mean should be 138.5, and then the standard deviation should be 29. And then the thing that we're looking for is the probability that x is less than 60. And if we go here and do it, so let's see, mean of 138.5, standard deviation of 29, and we wanted the probability that x was less than 60. Compute. Yep, little tiny number that goes with a little tiny tail, right? You can see the little tiny red tail there. And it's 0034 to 4 places. And yeah, that's a small number. That's a really low probability. That works out to about 1 in every 300 customers if you're selecting them randomly. So I guess realistically, somebody with an easy order going through at an off-peak time, I guess. Not going to happen too often. And then, oh, look at this. This isn't a probability. What's the cutoff for the longest 20%? This is actually a percentile question, but notice it's the longest 20%. So that's going to be over here on the right. So what this is asking for is, that's our cutoff, so that's our x that we're trying to find, then the longest 20% should be longer than whatever x is. So you'd have a 0.20 up there. I guess you'd still have a 138.5 in the middle, and then there'd be a 0.80 into the curve back there, right? Because the 0.8 plus 0.2 will add up to 1. So the cutoff for the top And this is actually worth writing out, I think. So cutoff for the longest 20%, this is the same thing as the 80th percentile, right? Because by definition, the percentiles are named by what comes below or before them. And on the graph, that's to the left. And look what's over to the left, 0.80. So this is the 80th percentile. So then if we're going to get that, then what we're looking for is, if I go back here, we've got to change, either doing it this way, since I've got it set up for a left tail, I can make this a 0.80, and you get the 162.907. Or if you want to do it the other way and say, well, it's specified a right tail, I'm going to specify a right tail of 0.2, right? So greater than or equal to with a 0.2 in there, and then same thing, 162.907. So then using StatCrunch, where we ended up was that x was equal to 162.907, or I think usually with the homework they want these rounded to 2 places, so we'll do that, 162.91 seconds. All right, so the ones where it's like this, where it's a percentile question, but they give you the other piece, like they don't just directly ask what's this percentile, like what's the 40th percentile or the 95th percentile or whatever. But they say like what's in the upper tail. You could do it directly, right? Because what I have set up here in StatCrunch, it's doing it directly. I've got a 0.2 in the right tail, and it's just here's the cutoff, 162.907. But if you want to think about it as though it's a percentile, you can do it that way too. And actually, if you were going to use something like Excel to do this, you have to kind of rephrase it as a percentile. StatCrunch has that extra flexibility where you don't. But if you're using a spreadsheet, you do actually have to make that adjustment. So that's kind of why I wanted to go through it, even though for StatKey you don't, or StatCrunch rather, you don't really need it. All right, one more example here. So loaves of rye bread distributed to supermarkets by a certain bakery, normally distributed with an average length of 30 centimeters, standard deviation of 2. All right, so if we have the average length of 30, then that tells me what I'm going to put right in the middle of this picture. Let's see, and then a randomly selected customer selects a loaf of rye bread, and what's the probability that that loaf is longer than 31.5 centimeters? Okay, so maybe about here. The 31.5. And longer is going to be to the right in the picture, right? Bigger number if it's longer. So then when we go to StatCrunch, what we're going to have to do is we're going to have to put in a mean of 30, and we're going to have to put in a standard deviation of 2, and then we want the probability that x is greater than 31.5. Okay, so if we go to StatCrunch, mean of 30, standard deviation of 2, and then greater than, which will have to be written as a greater than or equal to, 31.5, and we get 2266 as our probability. All right, so 0.2266 for that probability. And then the other one, it's not a probability, it's a cutoff. So if it's a cutoff, that's a percentile question. And there are a bunch in this homework assignment. So what's the cutoff for the shortest 10%? So notice this time it's the shortest 10%, as opposed to, if I scroll back up for a second, here it was the longest 20% of drive-through times. Shortest is going to be on the left, right? It's going to be smaller numbers. So we're still going to have our mean of 30. I guess I can draw that in. And then shortest 10%, you'd be way over here. And I guess then we're looking for our x, where we've got 0.1 in the tail and then 0.9 up there, everywhere else. So, all right, well then we can go back to StatCrunch, and then we just say, I think I would flip this around and say I want 0.1 in that tail, in that left tail, right? And then here's where having this shaded picture really helps. You're like, okay, the shaded part's on the left like it's supposed to be, right? That's a good check to have in there. And what we get is about 27.44 to two places. All right, so then what we're going to get from StatCrunch is that x is 27.44 centimeters. So 10% of the loaves of bread from the bakery are shorter than that, shorter than 27.44 centimeters. Okay, and that is about it for 6.2. It's all these types of questions where it'll be sort of an applied situation, and either you have to get probabilities or you have to get percentiles, and anything that talks about a cutoff is a percentile question. Although it might have the cutoff for like the largest 15% of values or something. So if it's the largest 15%, you want that 15% in the upper tail, not the lower tail. So there is that, right? There are those situations that are going to come up. The other thing is that at the end of the homework, there are a couple of problems like this that are really long-winded because sometimes it just works that way. The ones in here, there's not a ton of wording, right? If I go up toward the top, like the explanation of what's going on, like the explanation of the context up here, it's pretty short. But I think there's one, maybe two, depending on how you look at those paragraphs or what you consider to be long, that would be considered kind of long and wordy. But you still basically do the same stuff. But I did want to mention that there were a couple where the paragraph looked kind of big. And I figured it was worth giving you a heads up about that.